Today we are going to discuss the factors affecting the position of dynamic equilibrium in a reversible reaction. In the first 5 minutes, I will summarize all the factors because we have done previously. And in the second part, we'll discuss the examiner questions, the past paper questions. The most important part is this because in equilibrium, we usually understand the questions, the concept, but the questions are a bit harder. So I need your complete attention today. First, I'm going to explain all the concept in a quick session. Look at this. I told you if the reaction is reversible, look, here is a reversible reaction. This is reaction happening in a closed container. The reactants and the products, we know in a reversible reaction, the mixture contains all the reactants and products. Okay. Now in our mixture, there are 4 in total. This is known as reaction mixture or equilibrium mixture. So we need to understand the terms which examiners use when they say equilibrium mixture. So what they are asking, all the reactants and products which are present at the equilibrium. Okay. One thing, equilibrium mixture means all the reactants and products which are present in a reaction at equilibrium. Okay. In this case, the equilibrium mixture, let's say, contains 5 moles of all these. So our equilibrium mixture contains 5 moles of each, the reactant and product. And then they say how the percentage or yield. They use a word percentage yield or yield. So they are asking you the percentage or yield of a specific reactant or product in this reaction mixture. So if I say that the percentage yield or the yield of D is increasing, if I say in my reaction mixture or in my equilibrium mixture, the yield of D is increasing. So what I'm trying to say, but that my reaction is shifting the equilibrium to the which side? To the right hand side, to the forward side. Okay. When I say that the percentage yield of my D is decreasing, so what I'm trying to say by the equilibrium is going to shift to the left hand side or the backwards. Okay. And they usually talk about in percentage. For example, I can say, instead of saying कि 5 moles hai, I can say like this. I'm not going to say what precise amount of the reactant and product is this. I say in my equilibrium mixture, 25% of D, 25% of C, 25% of B, and then 25% of A is present. But then I say by changing the temperature, the percentage of D from 20 increase from 25 to 40%. What does it mean? The reaction equilibrium shifts in which direction? Forward or right hand side. So these are the terms which the examiners use. I hope you now understand what terms they use and what is the meaning of those terms. The percentage yield of everything in the reaction mixture or equilibrium mixture, how the equilibrium mixture shifts. Okay, now there are 3 factors which affect the equilibrium position. Number 1, concentration. Number 2, temperature. And number 3, pressure. We have discussed them in detail. I'm just going to go through quickly each of them, then we are going to do the questions. Okay. First one, concentration. How it affects the equilibrium position. For example, in this above reaction, this is the position. I have 25% of each ABCD in my equilibrium mixture. Concentration, how it affects. Can I have your attention, please? Excuse me. How it affects the concentration. Adding anything here shifts equilibrium to which side? The reaction always respond to the change And how it responds? It tries to nullify or reduce the effect of that change. So adding A, the reaction will respond to consume the extra amount of A. And in order to consume the extra amount of A, it has to shift the equilibrium to the which side? Right hand side of the forward. Because the extra amount of A that has been added, they have to consume it. Similarly, if I remove A, what do you think? A is removed. How the reaction is going to respond? Yes, the reaction is going to try to make that amount of A that has been removed. And in order to make the amount of A that has been removed, the reaction has to go to the which side? Backward. So for the concentration, kids, you have to see where you are adding and where you are removing. Okay? And then you have to decide which side its reaction is going to go or shift its equilibrium. On the other hand, for the temperature, you don't have to see because the which side. For the temperature, you just have to heat the mixture. So for the temperature, we have to see the delta H. If the delta H is plus 100 on this side, it means the reaction goes forward and absorbs energy. Is it? So if you heat it, it absorbs energy and goes which side? Forward, because it goes forward endothermic. So this reaction is absorbing energy and going forward. So if you heat it, obviously it is absorbing energy, so it has to go to the which side? Forward or the right hand side. On the other hand, if the reaction delta H is minus 100, what does it mean? That its reaction goes forward and releases energy. What is going to do? Release energy. So it means it is what? It is exothermic. So if you heat in this case, this is not good for this reaction to go forward. In this particular case, if delta H is exo and you heat it, so it's not going to go this side. It's going to go which side? Backward. Because in the forward, it is releasing energy. In the backward, it is absorbing energy. In the backward, it is endothermic. So when you heat a reaction, which is exothermic in the forward direction, it's not going to go forward. It's going to go backwards. So now the second thing is done. For the concentration, you have to see which side is being added and which side is being removed. For the temperature's effect, you have to see what type of reaction is this, exo or endo, and then you have to decide which side the equilibrium is going to shift. And for the third one, if you look at the pressure, pressure only affects if the reaction mixture contain one or more gases. And on the other hand, if the number of moles of the gases, as in this case, you see 1, 1, 1, 1 is equal. So there is no effect on the pressure. And on the other hand, if the number of moles are unequal like this, now 2 and 1, 3 on this side, and 1 and 1, 2 on this side. So it means if you increase the pressure, the volume, or the number of moles where the less, it's going to go to that side. So if I put a pressure on the top here, which side the reaction is going to go? Where the less moles are there? Left hand side. So this is how you look at the effect of pressure, temperature, and concentration. Now, are you ready to go for the questions? Okay, let's go on. Here is the question. No, the examiners don't ask you the direct questions. They just twist the questions wording, but the concept, if you know, you can easily answer them. Just stick with your concepts, okay? Here is the question. Hydrogen iodine react together in a reversible reaction. Hydrogen iodide is formed, right? I would like you, because I'm going to scroll up, so I would like you to write this equation along with the colors and everything, please. Hydrogen, all those who are on the Zoom and those who are present here, please write this equation along with the state symbols and the colors, because I'm going to scroll up. Okay, now this reaction says, please write down this information as well. This reaction is what? Exothermic in the forward direction. Okay. Now, A gas syringe containing an equilibrium mixture was sealed and heated to 250 degree. Equilibrium mixture was pale purple color. What is meant by term equilibrium? So first of all, we have to define the equilibrium. When the rate of, please write down, when the rate of forward reaction is equal to the rate of backward reaction. This is 1 mark, okay? If you write this part of the definition, you are not going to get 2 marks. This is 1 mark. For the second mark, you have to write and the concentration of reactants and products becomes constant. The plunger of the gas syringe was pressed in a while. The end of the gas syringe was blocked. This increased the pressure. So he's just trying to change the wording. What he said, that the pressure is increased. The position of equilibrium did not change. Position of equilibrium did not change. So what is he trying to say? That the pressure is increased, but the position of equilibrium did not change. Right? This color of the gaseous mixture turned darker purple. Give a reason why the position of equilibrium did not change. Can anyone please look at the equation and tell us, if the gas is there, then the pressure will affect the equilibrium position. But here he's saying, although gases are there, but the increase in pressure will not shift the equilibrium position. Why? Give the reason. Yes. So whenever you have to look at the pressure, you have to refer to the number of moles. So you can clearly see there are 2 moles on this side of the hydrogen and iodine in all together, and 2 moles of hydrogen iodide on this side. So what you are going to write, number of moles are equal. But you have to mention the gases. Equal moles of gases on both sides. Okay, we're going to skip this. This is kinetic particle theory questions. Okay, the temperature of the gas syringe was increased to 300. But so the temperature was initially 250 and the temperature is increased to 300. Okay, this equilibrium mixture where this gas H2 plus I2 gives us 2HI, pressure is increased. The temperature is increased from 250 to 300. What happens to the position of equilibrium when the temperature of the gas syringe was increased from 250 to 300? What happens to the position of equilibrium? For the sake of reminder, I can tell you that it was clearly written that this reaction is what? Exo in this direction. Exo mean releases energy in this direction. And what we are going to do? We are going to heat. We are going to make the reaction to absorb energy. So obviously it's not going to go forward. Why? Because it releases energy and goes forward. And when we are making it to absorb energy, so which direction is going to go? Left hand side, right? So what you have to write, please write down the position of equilibrium shifts to left hand side. Although in this case there's only 1 mark, but when you have 2 marks, you have to explain why. As this reaction being exothermic, in forward, gives out energy going forward. So I used his wordings in the question that this reaction is exothermic in the forward, means gives out energy going forward. So when we increase the temperature, it's not going to go forward. Or you can use the alternate words like this. The position of equilibrium shifts to the left-hand side as this reaction. Please write both answers. As this reaction absorbs energy and goes backwards, being endothermic in backward direction. So you can write any answer if you have a 2 marks question. Okay, now the next part. I raised it because in this particular question, you need only 1 mark. So you just have to tell which direction equilibrium is going to shift. Right? What happened to the rate of forward reaction and the rate of backward reaction when the temperature of the gas syringe was increased? Let me tell you before you answer this. The rate is regardless of exo and endo. When you increase the temperature, the rate always increases. So you don't have to see, you don't have to bother, is it exo or endothermic? Rate always increases. So what do you think? What happens to the rate of forward reaction?
Increases and increases.
And what happens to the rate of backward reaction?
Increases.
Increases. So this is what the examiner do. They put in the rate question with the equilibria. Okay. So where the students get confused, they start thinking the effect of temperature on the rate in context of exo and endo. Okay. So you're not supposed to think like this. There's no exo endo. Okay. Next. Cobalt is a transition element. Potassium is in a group 1 of the periodic table. When cobalt chloride is added to water and equilibrium is established, I would like you to write the equilibrium and the color as well. Quickly. Please write this equation with the colors. A student adds water to the blue solution of this. Describe what the student observes. Give the reason for your answer in terms of position of equilibrium. Ji bacho.
The color changes.
Adds water.
The color changes from blue to pink.
Okay, this is the first part of your answer. Describe what student observes. Whenever the examiner asks you to tell us observes what is seen, so you just tell the color change. Okay, you start with the color change. So what is the color change?
Blue to pink.
Yes, so initially you will say the student observes the color changes from blue to pink, or you can use alternate words, more pink color, or you can say less blue color. So out of all these 3, you can use this word, these, or just this. But then when he asks you to describe means you have to give the reason why it happens so. Yes, as your name? Hamad is saying that equilibrium, position, shifts to right hand side. Ahmad, you have to give a reason. Since adding water, the reaction shifts equilibrium forward to consume the amount of water added. So please write down equilibrium shifts to the right hand side to consume. I hope you understand why equilibrium going forward. Why the pink color is getting more? Because you added water. So the reaction, I just told you, when you add something, reaction try to consume and go in that direction, the opposite direction. To consume the water added. Another student cools a blue solution. The blue solution turns pink. What does information indicate about the forward reaction? पहले तो ये देखें cool करने से the blue solution turns pink means by cooling equilibrium goes in which direction?
Forward direction.
Yes.
So the
And what
reaction
this
is
suggests,
exothermic.
why decreasing temperature if shifts the equilibrium backward, what does it suggest?
That the reaction is exothermic.
Sorry?
The reaction is exothermic.
This reaction is exothermic. I hope you understand. This reaction is exothermic in which direction? You have to tell them which direction. Like in the reversible reaction, you have to identify. Reaction is exothermic in
Forward reaction.
forward direction. Okay? Because decreasing temperature shifts the equilibrium to the right hand side. So that indicates that this reaction is exothermic in the forward direction. Next. Here it is. What is meant by term equilibrium? What is meant? Please write down. Please write down.
लिख दिया सर.
Okay, someone from here. Anyone? Anyone? What is meant by term equilibrium?
A position in which rate of the forward reaction is equal to the rate of the backwards reaction and the concentration of both products and reactants remain constant.
When the rate of forward reaction is equal to the rate of backward reaction. And the concentration of and the concentration of reactant and product becomes constant. Okay, next. The graph shows how the pressure affects the yield of, I hope you have copied this equation because I'm going to scroll up. Please copy the equation. H2 plus I2 gives us 2HI. All of them are gases. Okay, now please look at this graph closely, everyone. This is the reaction. H2 plus I2 gives us 2HI. Please pay attention. Okay. What is the yield of hydrogen iodide? I just told you yield of hydrogen iodide. Yield mean amount of hydrogen iodide. What is happening to the pressure? When the pressure is increasing, let's look at the one temperature only. These are the values actually at two different temperatures. So I'm gonna erase this. In other words, just forget about this. Now, just tell me, increasing pressure, how changing the yield of hydrogen iodide at 500 degrees Celsius?
No
Like
change.
I have mixed them together. The temperature is 500 degrees Celsius. Okay. 500 degrees Celsius is the temperature. And I change the pressure. The pressure is increasing, let's say. What is happening to the yield of hydrogen iodide?
No change.
At 500 degrees Celsius, this straight line tells me that there is no change in the percentage in the yield of hydrogen iodide. It means the pressure change is not affecting the equilibrium position at 500 degree. Now let's forget about the 500. The same thing we tried by changing the temperature. Then we changed the temperature to 700 and looked at the effect of this. What is the change? At 700, is there any change by changing the pressure?
No.
So in this reaction, whatever the temperature you have, you change the pressure, the yield is not affecting. So it means the pressure change is not affecting the equilibrium position in this reaction? Yes. Explain why the yield at 500 does not change as the pressure is increased. Now you have to tell us why.
Because they are equal moles of products and reactants.
Yes. Equal moles of the reactants and the product gases. So please do mention gases. Pressure ka effect hai, you cannot ignore the gas. Equal moles of the reactant gases and the product. What can we conclude from the difference in the yield of hydrogen iodide at two temperatures shown? Explain your answer. Now, you need to understand the graph, kids. What is he asking? What can we conclude about the difference in the yield of hydrogen iodide? Can you give any conclusion about the difference in the yield of hydrogen iodide at two different temperatures? When the temperature was 700, let's say the yield of hydrogen iodide was 10 volts. I'm just attaching number because numbers make you understand. At 500 degree, the yield of hydrogen iodide turned out to be 20. So it means in this reaction, when I decrease the temperature, which side equilibrium shifted?
Right hand side.
Because the moles of hydrogen iodide increased. So it means to the right hand side. By what? Decreasing temperature. So what type of reaction it should be? Exo or endo?
Exothermic.
Exothermic. Well done. So what? Explain your answer. What do you conclude? So we conclude that this reaction is, so you have to write it properly. The reaction is exothermic In which direction? In the reversible reaction, you always have to mention the direction, okay? Is exothermic in?
The forward reaction.
Yes, in the forward. As decrease in temperature shifted equilibrium to the right hand side or forward direction. Next. Okay, you have to write this equation, kids, please. CO plus 2H2 gives us CH3OH. Please copy this equation. All of them are gases. Okay, look at this. Now complete the table using only the words increase, decrease, or no change. Number one, effect on the rate of a reverse reaction. Adding a
Increase.
catalyst.
Increases.
No. Effect on not equilibrium position, Ahmad, on the rate. Increases. Rate of reaction हमेशा increase होता है. The rate always increases by adding catalyst. Increasing temperature, the rate increases. I'm just going through this like this. Rate of reaction, decreasing pressure. What happens to the rate? I'm not thinking about the equilibrium. I'm just thinking about the rate. Decrease in pressure, decreases rate because the gas is there. Now come to the equilibrium position. Adding catalyst has no change in the effect on the equilibrium yield of this, equilibrium amount of this. Okay. Increasing temperature, what do you think?
Decreases.
It's an exothermic reaction, bacho. So if you increase the temperature, where it's going to go? Exothermic in this direction.
Left hand side, so it will decrease.
So if you increase the temperature, which direction is going to go? Left hand side. When it goes left hand side, what happens to the yield of CH3OH?
Decreases.
Decreasing pressure. If you look at the number of moles, 3 on this side, 1 on this side.
Decreases.
Increasing pressure shifts where the less moles. Now we are decreasing pressure. So decreasing pressure will shift where? More moles. So which direction gonna go?
Left hand side.
Left hand side. So what happens to the yield of CH3OH?
Decreases.
Decreases. Sorry? वो कैसे?
Effect on the equilibrium yield of CH3OH. Exothermic into. Sorry.
We are increasing temperature now. So it's an exothermic, so it's going to go which side? So backwards. So the yield of CH3OH goes down because वो react करके backward जाने का मतलब है it reacts and changes into CO and H2. Okay? So obviously it's going to go less. Okay? So we'll continue with these questions, similar questions of equilibrium tomorrow or right. Thank you very much. That's all from my side.